So today's lesson is on the perimeter of composite shapes and how you find the perimeter of composite shapes. Now, before we go into today's lesson, make sure that you've taken a look at and completed the activity on investigating perimeter, because that will remind you of some key points related to perimeter that you need to consider and that will be extremely helpful when you're working on this next session on composite shapes. So, now, a question before we begin. What is a composite shape? So I've got a few examples. Here's one example to start with. And so what you'll notice is that it's a shape that doesn't fit into any one category when you learn about shapes or polygons, quadrilaterals, and so on. It looks like it's a mishmash of a bunch of different shapes, and this one in particular happens to be made up of rectangles. It looks like it's sort of like a U shape. So I'm going to show you a couple of other examples. So here are two other composite shapes. This first one, this brown one, looks like it's made up of a rectangle and
Mrs. Garrett, can you call 303, please? Thank you.
And a semicircle. So in order to so we'll talk about strategies to help us figure out the perimeter of an object such as this. Okay, now down here, I have a trapezoid, it looks like, right? So, but the issue with this question is that they don't give me the side length here and that they don't give me the side length here. And so this makes calculating the perimeter of this object a little more tricky. But these are all composite figures. They're figures that might be made up of more than one type of shape, all mishmashed together. That's what a composite shape is. And so I want to talk strategy because the calculation of the perimeter for composite shapes isn't any different than for any other shape, but you do need to make sure that you think of the composite shape in pieces and try to figure out all the pieces that you know and all the ones that you don't know. So I'm going to move over to my smartboard and start writing in some information that might be helpful. So when I look at this red shape, I want to put down as many measurements for the side lengths that aren't indicated in the diagram. And sometimes that means doing a little bit of thinking or some problem solving to put those pieces together. So I notice right off the bat that I don't have a length for this bottom side here. And if I want to know the total distance around this shape, then I'm going to need to know all of the missing sides. So that includes that bottom side, and it also includes, this side over here. So both of those sides are required, and so let's look at how we can figure this out. Well, this side right here, I know that it is the same height as the side opposite it. So I'm going to write in 8 centimeters. At least that's a reasonable conclusion. Often you'll see a little mark here on the side telling you that it's exactly the same. We're going to go ahead and assume that that's true. Now, for the bottom side, I'm going to look at this, and I know that the bottom side is made up of this little bit, and then a little, and then this little bit here, and then this little bit right here. And the pieces of that are given above. So I know that if I have 4 centimeters plus 4 centimeters plus 4 centimeters, that's going to give me 12 centimeters overall. So that's my strategy for solving the perimeter. And now to finally find the perimeter, all I need to do is to add up all of those sides together, right? Oops, I think we forgot one more. It's telling us that this side right here is 4 centimeters. And this side right here is the same height exactly, so I'm going to go ahead and write in that it's 4 centimeters. So, perimeter. So the perimeter is going to be equal to, and I'm going to figure out where you're starting. I'm going to start right here, and I'm going to get rid of some of my other ink. I'm going to rewrite the missing pieces. So we said that this was 12 centimeters down here. And that this is 8 centimeters here, and then, and then 4 centimeters over here. So I'm going to to start my road map right here. And I want to be able to travel all around this shape to get its perimeter. So I've got my 4 centimeters plus 8 centimeters plus 12 centimeters plus another 8 centimeters plus another 4 centimeters plus another 4 centimeters plus another 4 centimeters plus another 4 centimeters. And now I'm back where I started. Okay? And so by using my calculator, I can quickly add that up. 8 plus 4 is 12, plus another 12 is 24, 32, 36, 40, plus 8 is 48. I don't want to forget that I measured this in centimeters. So there I go. There is the perimeter of this composite shape. Hopefully you found that to be fairly straightforward. There were quicker ways to do this, just in case you're wondering. You can try to group. It looks like I have 1, 2, 3, 4, 5 groups of 4. I could have written that as a multiplication instead, and that may have been quicker. So just as an idea for you to try on your own. All right, so this next example is a little trickier. I'm going to break it down into the pieces that I need if I'm trying to find the distance around. So I can see that the distance from here to here is 3 centimeters. And it's a reasonable guess to say that this bottom part right here is also 3 centimeters. So I'm going to go ahead and write that in. I also have that this entire length right here is 8 centimeters, and that's really useful to me. So it seems like the only piece that I don't have right off the bat is this half circle right here. Okay, so you may remember that the perimeter of a circle has a special name, and it's called the circumference. So it looks like in order to get this piece right here, the perimeter of this half circle, I really need to calculate the perimeter of the whole circle and divide that number by 2. So I'm going to go ahead and do that. Okay, so you may remember that the formula for the perimeter or the circumference of the circle, C, is equal to pi times d. And so that means that the pi is always 3.14-ish, and there's a button on your calculator for that. But d is the diameter of the circle. And the diameter, you may remember, is the distance across the entire circle and passing through the middle. So that would be this line that I've drawn in green. So that appears to me to be the same length as the other side of this shape, 8 centimeters as well. So we're going to go ahead and use that as our diameter. Okay, so pi is around 3.14, but I can type in that on my calculator. My diameter was that 8 centimeters that I had before. And I can work that out on my calculator to give me a solid number for the circumference of the whole circle. And that gives me around 25.12 centimeters. But I don't really want the whole circle. I want just the distance from the red part. So I know that the red part is going to have be equal to 25.12 divided by 2. And that will give me the distance for that whole red part. So I'm going to write that in. And that gives me roughly around 12.56 centimeters. So I know how long that is. So the last step is to add up all of the distances around this entire shape. So I'm going to go ahead and get rid of some of my ink layer and start to make that journey around the shape. So I'm going to start in this corner down here. I could have started anywhere, but I'm going to start down there. And I'm going to go up this way. So the perimeter is going to be 8 centimeters plus this little 3 centimeters here, around this whole semicircle here, which was that 12.56 centimeters. And then this last little bit right to the end, this extra 3 centimeters. So adding that up will give me the perimeter of the entire composite shape. And I get 26.56 centimeters. If the question had told me to round to the nearest centimeter, then I would look at the 6. The number right after it is a 5, so I'm going to round up to 27 centimeters. And I'm done. So this last question is a little tricky, and I'm going to explain to you why. It looks like it might not be, but in order to get the perimeter of this entire shape, I need to get this distance right here. And that's not given to me in the problem, right? But, and that's a problem. So it looks to me like this is a right angle triangle, and so I'm going to have to use Pythagorean Theorem to figure this out. But you'll notice, so what I'm going to do is I'm going to just draw this triangle right here over on its own. Okay, this guy right here. I'm just going to take it and I'm going to draw it on its own. And so let's put in what we know. I know that this side is 5 inches. And I know that the side that I don't know is the hypotenuse of this triangle, because the right angle is directly across from it. But I also need to know another side. I can't have 2 sides that I don't know, and so I need to somehow figure out what the length of this side is. So let's look at the original diagram. So I know that the entire length on top is 22 inches. And I know that the entire length on the bottom is 9 inches. And so I know also that this little triangle right here is the same size as this little triangle right here. So the difference between 22 and 9 tells me what these 2 little pieces are, and if I divide that number by 2, I'll have the exact length of one of the sides. So I'm going to quickly do that. So 22 minus 9 is going to give me 13. And so now I know that 13 inches, the difference between 22 and 9, have to be split between these 2. So 13 divided by 2 is 6.5. So, and let's just check that out. 6.5 plus 6.5 is 13. Plus 22 will, plus 9 will give me 22. So that works out. So now I can say that the top side of this triangle over here is 6.5. So that will help me now to figure out my unknown side. It's my hypotenuse, so I'm going to call it C. So solving for C, I know C squared is equal to A squared plus B squared. So that's going to be 5 squared plus 6.5 squared. 25 plus, I don't know what 6.5 squared is, so I'm going to have to plug that into my calculator. That's 42.25. Cleaning this up again, I get 67.25. Now I'm going to take the root of both sides to undo this square. And that's going to give me 8.2 roughly. Okay. So now I can go ahead and I can say, get rid of this whole ink layer here. Now I know that the value of this length right here is 8.2 centimeters, and I can safely say that the length over here is 8.2 centimeters. And now I have the lengths of all the sides. So to finish off, I would simply add those up by saying 22 plus 9 plus 2 times 8.2, and that will give me the perimeter